I don't know. I guess we're going. Okay. All right. So I'm going to go ahead and put my work down here, and we'll see what you got. Hopefully you're ahead of me here. Okay. First one is not hard. Again, we got a GCF, and then what multiplies to -8 and adds to -2? What are those two answers? There are students in here. They just don't want to answer questions. What multiplies to -8 and adds to -2? -4 and 2. Okay, and then that means you have three zeros. X equals 0, x equals 4, x equals -2. Then, of course, in reference to our last example, if I made this some sort of inequality, these would be the x-intercepts. The graph would be again like this, and blah blah blah. All the things that we're supposed to know. This is 100% review from last year as well, or even 2 years ago, depending on what year you are. And then the problem with this one is this is infactorable. Nothing multiplies to -10 and also adds to be -6. Once you have that happen, it's the opposite of b, plus or minus the square root. Now, -6 squared is 36. I'll type that on a calculator like a robot. If it's a big number, I get scared about that. If you ever put a negative number in this position, you're missing something. Okay, a negative times a negative is a positive. All right, b squared minus 4ac, get back into the song, all over 2a. All right, and then do your calculations, but we got 40. Is that 76 on the inside? So this is a negative times a negative, and then that's 40 plus 30, 76, right? Right. Okay, thank you. All right, 76. Probably at least 4. Wait, 4 goes in the 80 20 times, so 19. 4 times 19. So 76 is 4 times 19. The square root of 4 is 2 minus a negative. This was minus, and that was a -10. So I went ahead and canceled it that way. That's the minus negative part of the product. You okay or no? If I would have multiplied this times this times this would have been a negative, but it's minus 4ac. Got it. So a negative cancels. It's a minus a negative built in there. All right, and then this becomes you divide this out this way. 6 over 2 is 3, and then 2 over 2 is 1, and then that's what you get. By the way, I don't know if we had this happen. Maybe it happened in the BCers. Those are actually decimals. I know I did that once in the notes. So if I had to solve an inequality with this, you would just do 3 plus root 19 and 3 minus root 19 on your calculator, get those decimals, and those are x-intercepts. We need to understand that. These are not I numbers. So, just keep that in mind. But this is not what's happening on this. You're just finding the zeros. Love when that happens. Oh, and then there's one more zero. X equals 0. Don't forget that one from that x that's sitting out there right there. So x equals 0, and then x equals the quadratic formula values. Okay, now we're getting to it. Now we're getting into what really yesterday was about, and I know I forced those notes right at the end. I think most of you were watching, but then I saw some stuff in tutoring that I didn't like. It's like we didn't get the process. So we'll go over it again. But I don't need synthetic division on this. This has a greatest common factor of x squared. Sorry, trying to think. Okay, so if you can factor, so the first thing you look for is, can I factor these things? And if you can do it, then if you can't, you'll see what happens. That's when we got to think about synthetic division, where your mind has to be tonight on our homework. Okay, so find all the real zeros of the function, find exact whenever possible, and then later, this is when we're going to use our graphing calculator to help identify some things. All right, so we got x equals 0, and that's going to be a multiplicity 2. And then x equals, come on, subtract 4, divide by 3. We got to be able to do that just thinking about setting that equal to 0. What are my next steps? Subtract 4, divide by 3. All right. We should know these basic solving skills. Okay, now just understand, I do this often. I don't know. God. I don't know how I can get rid of this thing happening. Hate you, OneNote. Anyway, we're done. We're done with that question. It's over. Move on. But I just want to get it in relation to what I did in the bell work. What we need to know then is this. The graph of this cubic, which would look like this, has a 0 here, and then let's just be crazy and say -4/3 way over here. But that 0 is a bouncer, and I'm getting too many people that don't know this. I don't know why. Okay, you got to lock it in. If it's a cubic or multiplicity 3, 0, then it goes through like a cubic, but it goes through, but not multiplicity 2. So that's what that graph would look like, and then I'd be able to solve an inequality. Way, 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 way too many people are not doing this. Unacceptable at this point. It really is. Right? Now, we got a problem with this one. When I have 4 terms, and we did great on this on the board, what type of factoring should we look to do? When there's 4 terms there. Starts with a G. Someone said GCF, you're right, because I keep forgetting to look for one, but there isn't, but it's grouping. Here's the thing though, we should be able to see this right away. The power of grouping is when I group, the parenthesis left over is equal. There's no way that's going to happen. I pull out an x squared out of this, I get x minus 6. I should get x minus 6 with left over when I pull something out of this. It doesn't occur. So this cannot be factored by grouping. So now we're stuck. All right. So here's what you're going to do on this. You're going to put this together. This is why I did this for bell work and analyze this again and did this for bell work. This one right here, zeros turn into x-intercepts. I'm going to plug this in the calculator and try to find an x-intercept that's perfect, nice and solid. One that I know is a nice little integer perhaps, or maybe a fraction I understand. So that's what we're going to do right now. I cannot factor this. I have no way of finding other zeros. I haven't shown you another thing yet. We're going to wait on that. We're going to go right to the calculator. And I'm going to go up here. I don't like doing the calculator over there. So I'm going to type x cubed, carrots delicious. Remember I told you, anyone have a dog? Anyone have a dog? All right, they love carrots. It's a nice healthy snack for them if you run out of, those dog bones or whatever. My dog hates dog bones, never eats those either. Little snob dog. He likes the fresh treats from Sam's Club. Ooh. I'm broke though; those are expensive. So he gets carrots only. Okay, so type that in. All right, and then just because you don't know where your calculator's at right now, go to Zoom Standard, meaning we may have messed with your Windows way back when, and your Windows may be real crazy. So hit 6. Okay, I'm looking at this. Oh, okay, I don't know if you can see me over there. I always like to have this double thing here where you can see me in the class here. But this 0 ain't so hot. I don't know what that is. I don't know what that 0 is, but what's that one? What does that look like it is? 4. That's what we're going to lock into. If this truly is 4 as a 0, then what should happen is I should be able to synthetically divide by 4. Now, remember yesterday it was opposite, remember? But 4 is a 0, so that means x minus 4 would be a factor. So we're still doing the same thing. It's the opposite of x minus 4. It's 4 that goes in there. There's another thing with synthetic division, that whole opposite thing, know when to use it. So when you're dealing with a factor, then you got to turn it into a 0. This is a 0, right? So 4 goes there, not -4. So that's number 1. This is some things that students screw up. Number 2, Rutrow. Oh, hey. Oh. Where's the name? Oh, Tom? Thomas? Yeah, yes. Yeah, I don't know what that is. Just go ahead and clear that out. Okay, and then sorry, we're in the middle of a video here. And then what should I get at the end? What should I get? Yeah, go down. What should I get at the end? 0. Okay, and then that will prove what I'm looking at is true. So again, that's why we did that bell work. X-intercepts, zeros, and so on and so forth. Okay, sorry not to go over this too fast. First step is you bring down the 1 and then you multiply and then throw that number over here and add. Add, not subtract. In regular division, you subtract just like in grade school. Then you do it again. 4 times negative 2 is negative 8, and then you put that number here and add and get negative 1. 4 times negative 1 is negative 4, and then boom shakalaka. That proves what I saw was correct. Makes sense. True. So on and so forth. Okay, now what do we have? We have a depressed polynomial. This has been knocked down a degree. So we turn this into 1x squared minus 2x minus 1. And do we have that right off the bat? A non-factorable situation? That's rough. Because nothing multiplies to negative 1. What multiplies to negative 1? 1 times negative 1, right? And then adds to be negative 2. You've got to be kidding me. Anyone? Opposite of b. Oh, and don't cry. Look at the numbers, for gosh sakes. You know, I'm so abused. The quadratic formula. This is so much work. Someone over here happened to say that. All right. Opposite of negative 2 plus or minus b squared minus 4ac all over 2a. All right, so this is 2 plus or minus. Okay, you watching? What, right? This is a negative times or negative minus a negative. I can do it that way, and then I get 8 in there. Hey, what's 8? A number. What's 8? 4 times 2. What's the square root of 4, everyone? What's the square root of 4? Nobody? Oh, when I said nobody, more people answered. That was great. Interesting. All right, and then I'm going to reduce up here. So split this up into 2 fractions. I've covered this a million times. Biggest mistake people make is not canceling that 2 with this 2. All right, so what are my zeros? Don't forget the original one that we saw in our calculator, 4 as well. Hey, then I do want to come up here, or no, not come up here. I want to go to the graph again, and then let's slide this over. That's not as easy to do that way. It's probably easier to do this way. I'm telling you right now, 1, listen, 1 plus root 2 is that 0 right there in decimal form. So if I type 1 plus root 2 and I press enter on my calculator, I get 2 point something. And then 1 minus root 2, I get negative point something between 0 and negative 1. So that's what I mean about that. Those actually are x-intercepts. All right, and that may happen in the future when you have to do such a thing. Okay, let me do that so that keeps that open. Okay. Oh no, and then I said I wasn't going to do the 4th one. So I think this 3rd one really covers everything that you could run into. But the problem is this is an x to the 4th. So that means, listen, I have to depress this. I got to really knock this polynomial down, bring it back to earth. I got to bring it down to an x squared. So I got to double depress it. So we got to double depress it. So it's going to be fun. Think of this polynomial as that person in the hallway that you just don't like. I'm just kidding. That's terrible, 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 terrible. Terrible thing for the kids there. Okay, so let's type it in. 2x carrots delicious dog. Remember what I told you? Minus 7x cubed. Get out of it. You notice I keep arrowing out. It's so annoying. I mess that all up all the time. I'm up there, then I type minus 8, and it's still up in the exponent. So try to get away from that. It hits me all the time. It gets me. I can't stand it. 14x and plus 8. Now this one's not going to be great. We're going to have to make a conjecture here. Hit enter. Okay, I got a bunch of zeros. Did they give you a pass? Yeah. Yeah, good. I'm loving the beans off the stuff of the job. All right. Half the time they come back without a pass. I don't even know if they went there. Oh no, this is rough. Okay, so I got some things I might have to. Well, I got one good one, right? See that one right there? So that's negative 4. So I'm gonna have to show you something new, and this is actually something you're gonna use the rest of the year. Go back to y equals. I heard someone go. I hope they're okay over there. All right, and then put y2 equals 0. This is better to find zeros. All right, so we're all paying attention. I hear a lot of people yip yapping during the notes. Okay, It's all fine and great if you're working with someone, but you're missing the key components. So what I'm going to try to do is get these, which one of these three zeros are rational. Okay, rational, like nice little numbers. I'm assuming I know that one's 4. That looks pretty good, right? So I'm going to check these. New menu, watch, listen, learn. Step 1, thank you. Step 1, second calc, which is trace. So the second trace. I'll wait till everyone gets there. Okay, I'm done. All right, and the next thing, this only works if you put y2 equals 0. Then I could go, you don't want to find 0. This is a little weird. That's why I'm circumventing this button because it's a weird thing that you have to do. It's called left bound, right bound. It's better to do intersect. But you need two graphs to intersect. So it always kills me when someone doesn't put y2 equals 0. My intersect button isn't working. No, the functioner of the calculator is not working. That's who's not working. You did not put y2 equals 0. What are you going to intersect when you only have one function in there? All right, so second, calculate, intersect. Now watch how easy this is. I want to check if this one in the left, this looks like it's closer to this one. This one looks like it's right in the middle. Maybe I'm wrong. I'm going to check this one. So you arrow over to the 0 you want to find. Right, so I'm getting close to that one. But then this is what's goofy. First curve, press enter. Now you're on the second curve, you're on the red curve, just press enter again. Guess is a useless feature. I don't know why that exists. Press enter one more time until I see intersection. Yes. Why am I happy about negative 0.5? What is that? What's negative 0.5? What's the fraction? Negative 1/2. It's not irrational. Like the square root of 2 is 1.414. You'll get a non-terminating, non-repeating decimal if it was irrational. So I have my 2 zeros. I'm ready to rock and roll. Now, what would have happened if I looked at this one and it was a long decimal? I would have just tried to find these other two and see if they were rational numbers. So what was the first 0 that we saw that was nice? 4 again. So we'll start with 4. 2, -7, -8, 14, 8. And then bring down the 2. Again, for review of synthetic division, multiply, shove that number here, add. Same thing. I'm not drawing arrows anymore. 4 times 1 is 4. 4 plus -8 is -4. Then take 4 again, times -4, -16, -2, and then rejoice. 4 times -2 is -8. We saw what we saw, and it's been verified. 4 is a 0, so it's an x-intercept. And then we're going to find out later other things that we can do with this. I got to move this arrow, though. Now also got to move my fat head. Okay. Move over. He's stuck there. Okay. I just like knowing that we're in class. I don't need my face on the internet. Nobody's watching these videos anyway. And it's sad because I get 0.001 cent for every time someone watches my movie. So I need the money. And now, okay, so what was the 0 that we also saw? Negative 1/2. And it's probably smarter to make it a fraction. Okay, and notice what I'm doing. Now this is an x cubed. I'm knocking this down again, man. Just get you down to an x squared, man. All right? Knocking you down another level. Like I said, Mr. Samuels has been knocked down many levels. Negative 1/2 times 2 is -1, 0, right? Okay, so come on, I know how to deal with a fraction. This makes me cry too. Someone said, how did you get that? Is that calculus? All right, and negative 1/2 times 0 is 0. And then negative 1/2 of -4, boom, shaka, laka. What I saw with my eyes, which is how most people see, it's that negative 1/2 was, I don't know. All right, and then there it is. The paper's moving. Yay, I love life. All right. That was a positive statement, everyone. Everyone just relax. All right, so now this is 2x squared minus 4 equals 0. And now we can find the remaining 2 zeros. Add 4, divide by 2. What did I just say? Didn't I just bring up the square root of 2? Didn't I just bring up the square root of 2? Okay, so but be careful. So here are my zeros, and I think we can end this on this one. 4 negative. You don't have to listen to me. I haven't been listening since you started. Anyway, I'll do the last one just for giggles, and then you can start your homework if you want to watch. Fine. But notice what I put in front of the square root of 2. Plus, minus. You know what I'm going to do too? I'm going to go to the calculator. Now I'm going to show those other two zeros and prove. Here's my fat head again. Oh my gosh. Just can't get out of the way. Nobody even wants you here. I'm just kidding. All right. Second trace intersect. Okay. And then you go like this. Okay, so go to this one. This is going to be negative 1.414. I know that is the square root of 2's decimal. I've been doing math. There it is. See, there's the negative square root of 2. And then second trace, intersect, and then you have to go all the way over to that other one. It's actually this one, so we're getting close. And then that's all you have to do for the zero feature. Just get close to it and just hit enter 3 times. Guess, whatever. 1.414. That is the square root of 2. So again, this is all being taken care of here. But here's what you need to do, though. You have got to show the synthetic division. You got to show that you double depress this, because some of the answers, like when you're done, when you use the quadratic formula, you can't just guess what it is. All right, so that's got to be done. All right, ignore me if you want to. I will do 3 just for, or example 4 just for purposes of the video. Your homework is pretty simple. Let me see your homework sheet real quick. Oh, you know what I was gonna do? I was gonna do some on the homework actually. What would you rather me do? Do some of your homework or?
Do some of our homework.
Okay, we'll do that. All right. And then if you don't want to listen, that's fine. I don't know what this is. Just destroy this. Happily, just take something. I don't know what the heck this is. I don't know what. Somebody had some idea, and I don't want to do it. Okay. What time is it up there? What time do we got? Great.
You got the time in your little corner.
Right. I don't know where I'm going. Okay, I'm old and confused. Okay, I don't want to do 1 and 2. 1 and 2, I think, have rational answers, all 4 of them. But what you need to do is find one of the zeros that are rational, depress it once, and then factor. Got it? That's the idea. I think 3. Let me see what some of the answers are. Yeah, let's do 4. Let's do 4. No, 3 is factorable. No, 3 is easy.
Okay, then do 6.
3 is easy. Fine, I'll do 4 and 6. That someone keeps saying 6. 6, do 6, do 6. Fine, I'll do it. Oh, I gotta. Why? I know what. It's not. Jeez. Okay. All right. So same thing. Okay, same thing. You know what? Just he gone. All right. Tired of it. Okay. Can I even move this? Okay. All right. So first things first. This is not factorable by grouping. If I take an x squared out, that's x minus 13. This will not be x minus 13 when I take something out. It's no way. Okay, so y equals, real quick, clear, x cubed, carrots, arrow out, I hate that, minus 13x, hit the squared button so you don't have to arrow out of the exponent, plus 48x, minus 40. Okay, graph. Oh, I was going to say, if it's 4 again, 1, 2, 3, 4, isn't that 5? Yeah. That looks like a decimal. That looks like that's close, but not right on. I'm going to go with 5. So 5 looks like a 0. 5, 1, negative 13, 48, negative 40. Let's hope. And if I don't get this, I'll have to relook at that graph and say maybe it was a decimal, like that one over there that looked like 6, maybe. I don't think it was. I think it was just off. So this should give me a 0 when I'm done. I'm excited. 5 times negative 8 is negative 40, and this is 8. And by golly, 5 times 8 is 40. What I saw was correct with my eyes again. Anyway, And then what you should understand is you could do this. This was x cubed, now it's x squared, now it's x, and now it's a constant. So does anything multiply to 8 and add to be negative 8? No. So this is not factorable. Get ready to start whining. The opposite of b plus or minus the square root of b squared. That's negative 8 times negative 8, which is positive 64. B squared minus 4ac all over 2a. Okay, 8 plus or minus. Hey, at least this is subtract. Hey, 4 times 8 is 32. 64 minus 32 is 32. I'll write this one down above this. 32 is, you know what? It's 4 times 8, someone might go to, but then 8 is another 4. That's because 32 is 16 times 2. That's a better product. What's the square root of 16, everybody? 4. So it's 8 plus or minus 4 root 2 all over 2. So here are the zeros. They are x equals 5. And then cancel this correctly. So it's 2 goes into both 8 and 4, or separate it into 2 separate fractions in your head. Whatever you need to do in order to get 4 plus or minus 2 root 2. So many people do not divide this correctly, and it's upsetting. All right? And then lastly, you said 6 or else. 6 is easy. No, it's not. Okay, so I don't think this actually factors. But we should look to factor this because it's an x to the 4th x squared. It's possible. It's possible that this could factor. And I do want to kind of think about that. Because it could be that this is 2x squared and 1x squared. Because what's 2x squared times 1x squared? Just say this if you don't know what's going on. It's that. I don't know. So it's possible, but then 9 negative, if I put 9 here, that'd be 18, and then 1. No, that doesn't give me a difference of 7. The only thing that's left is 3 and 3. 2 times 3 is 6, but one of the 3's have to be negative so that you wouldn't get a difference that equals 7. So, okay, I'm just saying I know through numeracy and knowing how to deal with numbers, I could not get 7 as a middle term. So this is not factorable. So you know what I got to do? Got to go to my calculator. Okay? I got to go like this. I got to clear, and then 2x carets 4. Get out of the exponent, so annoying. 7x, hit the squared button, no exponent problems. Minus 9. Graph. Ooh. Oh, well, you got to be kidding me. What are the 2 zeros? 1 and negative 1. We're going to double depress this. Okay, but by the way, you ready? I'll do 1 first. By the way, tell me 2. What do I write next? 0. There is no x cubed and there is no x. If you don't do this in synthetic division, you're doomed. It will have no way of working. Okay, so I must take care of. So I'm kind of glad you asked this. A, talking about possible factoring of an x to the 4th x squared, but it doesn't. B, missing terms. Okay, bring down the 2. Multiply, add. Multiply, add. Multiply, add. Here you go. Multiply, add. And if this doesn't happen, you did something wrong. All right, and that's the problem. All right, so again, do understand, maybe make a note to self. This was x to the 4th. Now it's x cubed. So I got to knock it down again. You know what, though? Listen, if you get ahead of the game here, this is factorable by grouping. Can anyone see that? So this would be 2x cubed and 2x squared. I take a 2 out. And then this, 2x. And then this one, I take a 9 out, and I have x plus 1 left over in the parentheses on both parts. Does anyone understand what I'm saying there? So this actually cubic is factorable. It's actually factorable. But we'll stick with what I saw, that negative 1 was also a 0. And then this column's gone because we're now down to a cubic. That's the constant now, 9. 2x cubed, 2x squared, 9x, and then this is the constant. But don't really put just make a note to self that that's what that polynomial is now. I'm trying to just make sure everyone understands 0, and then, okay, that's still 0, and then that makes this -9. So what I saw was correct, 1 and -1. And now I double depress this sucker. This is not a quadratic formula. Actually, this is a great question that you asked. So the rest of the day, this is what I'm going to do, 4 and 6. Because then this is subtract 9. I don't have a middle term, so I'm allowed to just get x squared by itself. Then divide by 2. Oh boy, this is going to be, you know what I'm going to do? We're not going to worry about rationalizing a denominator, but we are going to worry about this. What's the square root of a negative? What's the square root of a negative? I. And then, hey, what's the square root of 9? 3. So up in the top, we could say like 3i over root 2. Was that too much? Do you get that? And then you're supposed to rationalize that denominator. I think we did kind of talk about that. I guess I will do it. One thing we got to do, though, is that's plus minus. Okay, again, whenever you square root both sides, it's plus minus. And then to rationalize this denominator, this is an old thing. You multiply top and bottom by root 2 because this is equal to 1. So you're multiplying this by a form of 1. This is, you know what, I don't really think that AP exam cares about rationalized denominators, by the way. I think this is a perfectly valid answer to leave. They won't mark you wrong. They don't care about that. Even in calculus, I don't think they care about rationalizing too much anymore. So anyway, my zeros are x equals 1, -1, and then you know what? Let's just say that. Let's just say square root of 9 is 3, square root of -1's I, 3i, and then square root of 2. Okay, we'll just leave it like that. I won't make you worry about rationalizing. But when you look at the key for this will say 3 root 2i over 2 because they'll rationalize. And then that's why up at the top it's 3i root 2. And then on the bottom, root 2 times root 2 is a free 2. So maybe just be ready for it, but it's not imperative. So I'll circle that. Okay, then we'll end that video. That was fun.